Hello, good afternoon, students. So let's continue from where we left, right? And we'll be doing the same chapters, which is electrostatics, as I told you. So let's continue with that. Today is 11th, is it? Yes, it is. Okay, so this is the chapter we are doing. I think we did complete this PDF with this. Yeah, oh, okay, almost. But there's still some things to go. So as far as I remember, we had done this, and we had done this question also, I suppose, right? This also had done. Yeah. This we are done, right? What about this, guys? This also we had completed. Then formula for electric field also we are done. Then this question also we are done. This also done. This is another question, but we'll rather go with theory, right? We'll talk about this, and then we'll go ahead and talk about the formulas. So what is this about? Let's see. Here what we are going to do is we are going to find out the direction of the electric field, right, on the transverse axis. So what do you mean by transverse? This means perpendicular axis, right? So let's say you have a rod here which has got positive charge, right? Positive charge, and there is a point P here. A point P is here, right? And at point P I have to find out the electric field. So that is what I have to do. You know, I have to find electric field at point P. So let's see how do I go about it. Direction I have to tell, right? And it's a positive charge. So due to positive charge, it's a rod. It's a positively charged rod. Because of this, what will be the direction of electric field? So at this point, from positive charge, fields go away from the positive charge, right? So x x direction component will be this, right? In x direction will be this, and in y direction where it will be, guys, because it's a positive charge, so positive charge pushes, right? So if it pushes, can you tell me, will it be upward? It will be more like pulling, right? Whereas we know positive charges pushes the electric field. Uh, so it would rather be in the downward direction, right? Pushing. So these will be the two components. Let's call it, this will be Ex and this will be Ey, right? So two components are here, Ex and Ey. Right. Now, what about this? Okay, let's talk about all the positive charges first. Then we'll come to negative charges. Perfect. Anyway, so we got some positive charge here, right? So at point P, where will be the electric field, guys? Electric field will be from the positive charge just away, right? Away. So it will be in this direction. Okay. and vertically it will be, it can't be towards, right? Because then it will go towards the positive charge. So it's, everything is away, so it's like here. Right? That is due to positive charge. Now let's go to negative charge. So we have this negative charge, negative, negative, and at this point, due to negative charge, it is towards, right? So x direction, it will be towards, right? Towards. And vertically, it will be where, guys, like as told, towards it, right? So more like towards means in the upward direction, to be attracted like this. And what about this case? Here also it is negative charge. So it will be again towards, and vertically it will be upward or downward. It will be downward, right? We can draw all these four cases, and then we'll go ahead. Okay, let's find that out. So I told you if this is a positive rod, let's say, so Ex and Ey will be in this direction, right? So formula for Ex is there, formula for Ey is there, both the formulas are available to you, and we get a beta here, right? Beta, sin beta comes here, cos beta comes, 1 minus cos beta comes here. Okay. Now, in which of the following figures the direction of electric field P is different from others? So you might want to take down the formulas because we'll be using this. So, and I'm not going to do the derivation part. If you want, I can derive it also. So you can message me here on the chat. Only one viewer is there. The chat, how to open chat? Acha, okay. You don't have to see the chat. No? Yeah. Oh, fine, sir. You don't have to look at the chat. No, that only. Okay. So Ex is there and Ey is there. We've got Ex and Ey. And the derivation is there in the book. It's quite lengthy. If I get into derivation, I won't be able to do the application part. And I think application is generally more important. And derivation we can skip, right? So I'll go to the or fine because let's do the derivation also. Fine, no problem. But it'll take a long time. That's about it. So I was thinking to not to go to it, but then it is there in the book, so I should do it. I should also do it. Fine, let's do the derivation. So we'll have to derive this formulas, you know, k lambda by L sin beta and k lambda by L 1 minus cos beta. We're going to derive these formulas. So let's see how we'll derive them. So let's go to the derivation part. For that, I will need. Let's take a diagram and we'll use it to derive it. Which diagram shall I take? Shall I take this diagram? We'll make our own diagrams. Come on, let's make our own diagram. So here it is. We put it the heading derivation. Derivation of electric field due to uh, rod, charged rod. You know. So let me write it down. Right. Let's go ahead. Electric field due to charged rod. Okay. Let's draw the rod first. So here is our rod, guys. This is our rod, right? Because of which I have to find out the electric field due to the rod, right? Let's draw the axis then. There you go. You have the axis. Nice looking axis here, guys. Right? Perfect. This is a better diagram than I thought I would be able to draw. Right? Good diagram. Now, let's say at one particular point, I'm interested to find out the electric field. Let's say at this point, right? At this point. And this entire thing is charged. Let's say it has got a charge of, so it's positively charged, let's say. Right? It's all positively charged. And because of this rod, I want to find out the electric field here. That's the entire story. Right? Moreover, this angle is given to me. This angle is, let's say, that angle is given. That's some angle. Let's say that is beta. Right? That is beta is the angle. Right? and we have to find out the electric field due to that. So for that, what we'll do, we will take an element from here. Okay. And let's say this distance is given to us, it is h. This distance is h, and it is making an angle theta, right? And let's say this vertical height is also given. This vertical height is, let's say, y. This is h, and this distance is fixed, right? Beta, you understand, is this angle, right? Between the white lines, this angle is beta, right? And what is this bottom line? Let's draw that also. And that distance is, let's say, b. Call the distance b, or L, whatever, right? I will call it b. Okay. Now, let us say at this height there is a charge, small charge element. We'll call it dq. Right? Dq is a small charge element because of which I want to find out the electric field here, right? So let's find out the electric field due to dq. Let's say this charge is dq, right? Awesome drawing, right? These tools are so good. I'm really enjoying making the drawings here. dq charge is there, right? Now what will that dq charge do is that that's a small element, right? It's like a point charge. So because of that, there will be some electric field at that point, The best part is I can make any corrections at any point. That's the best part about it. Rotation. Perfect. So let us write the electric field at this point due to this charge, yellow charge, and of course the electric field will be in this direction. Right. Let's call that DE, differential electric field, right? And it will have components, of course. Right, it will have components. Why it is not vertical? Should have been vertical. There's something wrong with this. How can it not make it vertical? Oh, that's really sad. It doesn't make it. There's no way it doesn't. It makes it perfectly vertical, right? You see. What does shear mean? Okay, nice. Not it's vertical, right? So D will have component, and what will be the horizontal component? If that angle is theta, this angle is also theta, and this will become what naturally? I hope you understand. This will become DE cos theta. Right? That's the x direction, right? So if I want to write down the electric field in the x direction, that is DEX, that will be DE cos theta, right? I hope it's clear to you. And see, as cos theta, we can simply write it as C, and sin theta, we can simply write it as S. So I'm going to use this shortcut C and S, right? Hereafter. Okay. And how much is dE equal to? You know, that is k cube r square, right? K q is that small charge dq by r square. Distance is what? H divided by h square. And cos theta is what? Cos theta is base, which is b, upon hypotenuse, which is h. So that's what it turns out to be. K dq b divided by h cube, kind of, right? That's differential electric field in the x direction, dE cos theta. I hope it's clear to everybody, right? No doubt there. Now, I can also write that small charge dq upon the small vertical distance dy, you see this and this distance is dy, right? So I can write dq by dy is lambda. Lambda is what? We have seen this already. Charge per unit length, right? Charge per unit length. That is your lambda. So we can use it here. From here I'll get that dq is equal to what? Lambda times dy. That I can substitute there, and it will become dq is equal to lambda times dy, b divided by h cube, right? This diagram is too difficult to draw, no? What I'll do is I'll draw this diagram now. Beforehand, I'll have a drawn version of this diagram, so I don't have to do all the construction. A lot of construction. Okay, anyway, so prepare. Let me take that as a note where I'll mention what all I have to write. Derivation I have to write down. I mean, I have to make a page for derivation. Let me write it down. Prepare derivation page. Page for what? Page for oh, derivation page for what? For deriving electric fields due to rod, right? So I've taken that as a note. Moreover, I had some other work. One second, just let me put a reminder for that as well. That work I have to do at 5 o'clock, and that is to create right. Like that, go ahead. Hello. So, till here, I hope everybody has understood. You know, actually, I messed it up. I've written cos theta as b by h. Let it be c only. Let it be cos theta only, right? So cos theta becomes c. You know, let it be c. Right? There's a reason. I want to keep things in trigonometric functions. That is easier to deal that way, right? And dq can be written as lambda into dy, that I've written, right? Let's put it there. Let's call this equation number 1, and I can write this is equal to k dq into divided by h cube square into c, and c is what? Cos theta, and the value of sorry, I'm putting the value of dq, right? It's k dq, and see guys, what is dq? The value of dq is this, lambda times dy, right, into cos theta divided by h square. Okay, so this is what we got. Now I want everything in cos theta, sin theta, all that stuff, right? So how do I get that? I can write h in terms of b. So I don't want linear parameters, right? I want to do the integration in terms of angular parameters. So I write here from where we got this. From equation 1. We got this. Okay. And so what I was saying, guys, I don't want to deal with linear parameters, means y, h, and all. I don't want to deal with. I want to deal with angular parameters, that is theta and all the stuff, right? So let's see what we can do here. And let me uh, lock all this. Nice. Okay, everything's locked now, so I can move this around. Perfect, right? Awesome. Okay, come on, guys. So, I wish I could have all this on the other side. Is it possible? I can reduce the size. No? I should have grouped and locked. Group and lock is what I should have done. My bad. Let me select again. I'll group it all and then I'll lock it. So, is there a group option? Combine, right? And then lock. Perfect. And now I can move it around all I want. Damn it, the hell? Move around already? Okay, you're locked, right? First. So, okay, I can keep it as a, I don't have to lock it then really, right? Without locking also, I can just move it around as a single object. I don't have to lock it, that is, since it is group, why the hell it's not getting unlocked? Okay, now it is unlocked, right? Perfect. Now this is a single object. Come on, get moved already. The hell, damn it. This is hanging. The board is not working. Too much experiment surely. But this was quite good an idea. I lock, I combine everything and then I keep it as a box. And then I toss around the box with the entire diagram getting moved around. Right? That's a great idea. Except it's not working now. What's wrong with the damage? Let me call the technical team to take care. Professor, that board has hanged. Board is not working. If you're having lunch, send someone else. Okay. Okay. Yes, sir. Nothing working. It will be there, no, sir. What I've done. I just have to close and restart. That's it, no, sir. I have to. Oh, it is there. Thanks, sir. I'll do it. Thank you, sir. Yeah, here it is. Okay. So, where were we at? dq is equal to lambda times dy we got. Where were we? I forgot. Okay, fine. So, we're treating this as an object, right? And we're moving it around. It's getting hanged because of that only. See? Again, same thing. That means the combination of objects can't be moved around. It messes with the app. Now it's hanged again. Oh, so restart it again. Close the program. Oh no, there it is gone. Did it get saved? That's gone. Entire thing is gone. Then I have to download it again. I have to make the diagram again. Again the same thing. Continuously hanging. Can only wait now. Oh, the diagram is back. Let me save it first. Save as. In the documents, 12th J physics. I'll first save it as it is. Right. Saved. Now we can always open from there. Open from here. Alright. Now we can continue. Now let me try that again. If it hangs, okay, fine. I'll not try it. I know it. Most definitely it will hang. So we'll leave that aside as of now, right? I think it's just not working now. I didn't do anything this time. right? Okay. Hopefully it will be fine. Combine, right? Again it is gone. Not working at all. See, same thing. Fine, let's not try that anymore. Okay, we'll not touch that part anymore now. Right, let it be. We just complete our derivation. So we have come till here, right? From equation 1 we have got this. Now as I was saying, let us retain the angular parameters. Let's retain the angular parameters. So dx will come out to be k. Now how do we get the angular parameters? See, what about y and h? What can they be written as? So to find to get h and b, which function I can write? I can write cos theta. Now I didn't do anything wrong. Now it's the same problem. So cos theta equal to b by h, right? From here I get that h is equal to b by c, right? And tan theta equal to y by b. That means y is equal to b tan theta. Tan theta I'm just writing as it as t. These are short forms I'm using. So if you differentiate, you get tan square theta is sec square theta d theta. That's equal to b by c square into d theta. That is dy. b by c square into d theta, right? And that value we can put it here. Oh, we've got a color band also. Okay. So time's almost up, but we have to complete this. We'll complete it next time because today almost half of the time went into correcting all this, taking care of the problem. So you see dy we are getting it as what? Dy is equal to b by c square into d theta, right? Now what we can do is we can put the values. So let's take the value of h from here and we'll put it there. Then we take the value of dy and then we put it there. And after doing all that, we get dex. Dx is equal to k lambda into dy. But what is dy? Dy is b by c square into d theta, right? This value b by c square into d theta, right? Into cos theta divided by h square, and h is how much? B by c. So b square by c square. Okay, so that's all the calculations we get, right? As you can see, and then we can simplify c square b and we get finally what? K lambda d theta up by b into c, which is cos theta, right? And now it can be very easily integrated, right? So I'll save it as of now. We'll continue from here next time. It's almost done. You just integrate cos theta will become sin theta. Integration of cos theta is sin theta, and we'll get the x component, right? Then we'll get the y component tomorrow. We'll carry on from here. I don't want to rush and complete, so I'll rather save it as it is. Well,